Ars Notoria, Episode 6, Chapter 1, The Myth of a Single System. The illusion of singularity. You are not inside a system. You are inside many. This is the first misunderstanding. Most people try to understand the world as if it were structured in layers that can be isolated, studied, and controlled independently. They believe in systems as separate environments. The social system, the economic system, the technological system, each treated as if it exists on its own. This is convenient, because it simplifies perception. It allows the mind to categorize, to separate, to analyze without conflict. But it is not accurate. No system exists in isolation. Every structure overlaps with others. Every rule interacts with other rules. Every influence is shaped by multiple sources at the same time. What you perceive as a single environment is a convergence point. You are not moving through one structure. You are positioned at the intersection of many, and each of them is acting on you simultaneously. Some shape your behavior. Some shape your perception. Some shape your decisions without appearing to do so. You do not experience them separately. You experience their combined effect. This creates a distortion, because when multiple systems operate at once, their boundaries disappear. The mind compresses them into a single experience, and what feels like reality is actually a merged output. This is why most people misinterpret control. They believe influence comes from one source, one authority, one structure, one system guiding outcomes. But influence is rarely singular. It is layered. And when layers overlap, they create reinforcement. A behavior is not shaped by one rule. It is shaped by multiple aligned pressures. A decision is not guided by one influence. It is guided by several converging pathways. This makes control harder to detect, because no single system appears dominant. Instead, dominance emerges from alignment. When multiple systems push in the same direction, the effect becomes strong, without appearing forced. This is where perception fails, because the mind searches for a central cause, a primary source, something identifiable. But there is no single origin, only convergence. At this level, understanding requires a shift, not toward deeper analysis, but toward broader integration. The system must begin to see multiple structures at once, not sequentially, not separately, simultaneously. It must recognize how different systems intersect at the same point, how they reinforce or counter each other, how they compete for influence. This changes everything. Because once multiple systems are visible, control is no longer simple. It becomes relational. What appears as a stable environment becomes dynamic. What seemed predictable becomes conditional, because each system introduces its own logic. And these logics do not always align. Some systems reinforce behavior, others disrupt it. Some push toward stability, others introduce volatility. You are positioned within all of them, at the same time. This is the reality most people never see. They operate within a compressed perception. They respond to the combined effect, without recognizing the components. This makes them predictable, because they react to outputs, not structures. But once the intersection becomes visible, something changes. The system no longer sees reality as a single field. It sees it as a network of overlapping influences, each with its own rules, each with its own direction, each competing for control over the same space. And that space is where you exist. Layer collision. Once multiple systems are visible, another assumption collapses. They do not coexist peacefully. They collide. At lower levels of perception, systems appear stable. Each one seems to operate according to its own rules, producing outcomes that feel consistent over time. This creates the illusion of separation, as if each structure occupies its own domain, interacting only when necessary. But this is not how systems behave. every system expands. Every system seeks to extend its influence beyond its initial boundaries. And when expansion occurs, boundaries overlap. This is where collision begins, not as an event, but as a condition. Two systems do not need to engage to interfere with each other. Their existence is enough. Because when two structures operate within the same space, their rules begin to interact. And rules are not neutral. Each system imposes its own logic, its own constraints, its own feedback loops, its own directional bias. When these logics align, the effect is reinforcement. Behavior becomes easier. Decisions feel natural. Outcomes stabilize quickly. This is why certain environments feel effortless, because multiple systems are pushing in the same direction. But alignment is not the default. Most systems operate with different objectives, different structures, different priorities. When these differences meet, they do not merge, they interfere. A rule from one system may contradict a rule from another. A feedback loop may amplify behavior that another system suppresses. A constraint may limit movement that another system depends on. This creates tension, not always visible, not always dramatic, but constant. At this level, conflict is not an exception. It is the baseline. Every decision you make exists within this tension. Not between right and wrong, but between competing structures. One system may reward a behavior, another may penalize it. One may encourage speed, another may require delay. One may amplify visibility, another may restrict it. You are not choosing freely, you are navigating collision. This is why simple decisions feel complex, because they are not evaluated within a single system. They are processed across multiple, and each system applies pressure in a different direction. This creates friction, but more importantly, it creates distortion. Because when systems collide, outcomes are no longer clean. A behavior that appears effective in one structure may fail in another. A strategy that works under one set of rules may collapse when another system interferes. This makes prediction harder, not because the system is unpredictable, but because multiple structures are shaping the same outcome. At this level, understanding requires more than identifying systems. It requires mapping their interaction. Not just, what is this system doing, but how does this system affect another? And more importantly, which system dominates when they collide? Because collision is not equal. Some systems override others, some adapt, some dissolve. Dominance is not random, it follows structure. A system with stronger feedback loops will persist longer. A system with tighter constraints will resist change more effectively. A system with wider distribution will influence more elements. These properties determine outcome, not visibility, not intention, structure. At this level, the system must stop thinking in isolation. It must track multiple logics simultaneously. How one rule interacts with another. How one feedback loop amplifies or cancels another. How one constraint reshapes the effect of another system entirely. This creates a multi-layered perception, not linear, not simple, but accurate. Because reality is not governed by a single structure, it is governed by interaction. And interaction creates complexity. But within that complexity, patterns still exist. Not within individual systems, but between them. And once those patterns are seen, collision is no longer confusing. It becomes readable. Invisible interference. Not all conflict is visible. In fact, most of it is not. At lower levels of perception, conflict is associated with disruption, clear opposition, observable resistance, direct contradiction between forces. This creates a narrow definition. If nothing appears to clash, there is no conflict. But at the level of systems, this assumption fails. Because systems do not always collide directly. They interfere. And interference does not require visibility. It operates through overlap. When two systems share the same space, Their effects combine. Not always in opposition, but not always in alignment either. This creates subtle distortions. A behavior begins to shift without an obvious cause. A decision feels less stable without a clear reason. An outcome deviates without a visible force acting on it. This is interference. Not strong enough to break structure, but sufficient to alter it. At this level, systems influence each other indirectly. One system modifies the conditions under which another operates, not by changing its rules, but by altering its inputs. A feedback loop that once reinforced behavior becomes inconsistent. A constraint that once limited movement becomes unstable. A pathway that once carried influence becomes less effective. Nothing is removed. Nothing is replaced. But everything is slightly altered. This is why interference is difficult to detect. Because it does not announce itself. It does not produce clear signals. It produces deviation. Small shifts in direction. Minor inconsistencies in outcomes. Gradual loss of alignment. Individually, these changes appear insignificant, but collectively, they reshape behavior. At this level, systems rarely fail because of direct opposition. They fail because of accumulated interference. Because over time, small distortions compound. Feedback loops lose coherence. Constraints weaken or misalign. Connections distribute influence unevenly. The structure remains intact, but its behavior changes. This creates confusion, because the system still appears functional, but outcomes are no longer consistent. What worked before no longer works the same way. Not because the system has changed completely, but because it has been influenced, indirectly. This is where most systems lose control. They search for visible causes. They look for disruption. They try to identify a point of failure. But there is none. Only interaction. And interaction does not produce a single source. It produces a field of influence. At this level, perception must become more precise, not broader, more sensitive. The system must detect variation within stability. It must recognize when outcomes shift slightly, even if structure appears unchanged. This requires attention to deviation, not large changes, but small inconsistencies, because these inconsistencies indicate interference, and interference indicates interaction. Once detected, something becomes clear. The system is not operating alone. It is being shaped, not by a dominant force, but by multiple subtle influences acting simultaneously. This changes how control is approached. Because interference cannot be eliminated, systems will always overlap. They will always interact. The objective is not to remove interference. It is to understand it, to map how one system alters another, to identify where distortions originate, to track how they propagate through structure. At this level, control becomes relational, not based on a single system, but on how systems affect each other. This is the shift, from isolated perception to interaction awareness. Because once interference is visible, conflict is no longer hidden. It becomes measurable, not through obvious signals, but through pattern deviation. And once deviation is understood, interaction can be managed. Competing logics. Once interference is recognized, another layer becomes unavoidable. Systems do not just overlap, they think differently. Each system operates according to its own internal logic, not in the human sense, but in structure. A system defines what is allowed, what is rewarded, what is suppressed, what is amplified. This creates a directional bias, not random, not flexible, encoded. At lower levels, this is invisible, because the system is experienced from within. Its logic feels natural. Its rules feel obvious. Its outcomes feel justified. There is no comparison point, so there is no conflict. But once multiple systems are perceived simultaneously, this illusion breaks, because different systems do not share the same logic. One system may prioritize speed, another prioritizes stability. One amplifies visibility, another restricts exposure. One rewards expansion, another enforces containment. Each system pushes behavior in a different direction, not aggressively, but consistently. This creates tension, not because systems are fighting, but because they are guiding. And guidance, when misaligned, becomes resistance. At this level, conflict is no longer about interference. It becomes directional. A single action can produce multiple signals. One system interprets it as progress. Another interprets it as risk. A third may not register it at all. This creates contradiction, not in the action, but in the evaluation. The same behavior carries different meanings depending on the system observing it. This is where confusion intensifies, because outcomes stop being absolute. They become conditional. What works in one structure fails in another. What is rewarded in one context is penalized in another. What appears effective locally collapses globally. This is not inconsistency. It is competing logic. At this level, systems are not interfering randomly. They are enforcing their own rules simultaneously. And those rules are not designed to align. Each system optimizes for itself, not for the whole. This creates fragmentation, because behavior is pulled in multiple directions at once. Move too fast, you break stability. Move too slow, you lose momentum. Increase visibility, you gain reach but attract constraint. Reduce visibility, you maintain control but lose influence. There is no neutral action. Every move is evaluated differently depending on the system. This is where most individuals lose coherence. They attempt to satisfy all systems at once. They try to optimize across conflicting logics. This leads to paralysis, or worse, inefficient movement. Because when behavior is shaped by multiple conflicting rules without prioritization, it loses direction. At this level, clarity requires separation, not of systems, but of their logics. The system must identify which logic is currently dominant, which system is actually shaping outcomes, not which one is visible, but which one has structural influence. Because dominance is not based on perception, it is based on effect. A system may appear powerful, but have limited impact. Another may be invisible, but define the outcome entirely. This is the shift, from observing behavior to evaluating influence. Which logic determines consequences? Which rules define boundaries? Which feedback loops reinforce or suppress movement? Once this is clear, tension becomes interpretable. Not something to eliminate, but something to navigate. Because competing logics are not a flaw, they are the structure. Every environment is built on multiple systems, and those systems will always push in different directions. The objective is not to remove conflict. It is to understand direction, to know which system to align with and which to ignore. Because alignment determines efficiency. When behavior follows the dominant logic, movement accelerates. When it follows a weaker system, resistance increases. At this level, control is not about acting more. It is about selecting the correct direction. Dominance hierarchy. Once competing logics are visible, one question becomes unavoidable. Which system decides? Because not all systems carry equal weight. They do not operate on the same level. They do not exert the same influence. They do not shape outcomes with equal force. Some systems guide, others determine. At lower levels, this distinction is unclear. Systems are perceived as parallel structures, existing side by side, each one contributing equally to behavior. This creates a false assumption that outcomes are the result of balance, that systems negotiate, that influence is shared. But systems do not negotiate. They resolve. And resolution follows hierarchy. At this level, every environment contains layered systems, not arranged by visibility, but by structural dominance. Some systems define boundaries, others operate within them. Some systems generate rules, others adapt to those rules. Some systems shape conditions, others respond to them. This creates hierarchy, not imposed, but emergent. A system becomes dominant when it defines the limits within which other systems must operate, not by being stronger in appearance, but by being deeper in structure. For example, a surface-level system may reward visibility, encourage expression, amplify output, but a deeper system may regulate exposure, impose constraints, limit reach. In this case, visibility does not control outcome, constraint does. The visible system guides behavior, but the deeper system determines consequence. This is dominance. At this level, systems are not evaluated by activity, but by control. Which system sets the boundaries? Which system defines what is possible? Which system determines consequence regardless of behavior? That system is dominant. Not always obvious, not always visible, but always decisive. This is where most misinterpretation occurs, because attention is drawn to active systems, the ones that produce signals, feedback, movement. These systems appear powerful because they are visible, but visibility is not dominance. A system can generate constant activity and still have limited control, while another system, operating quietly in the background, defines every outcome. This creates illusion, where individuals optimize for the wrong system. They align behavior with what is visible instead of what is decisive. This produces inefficiency, effort without result, action without impact, strategy without control, because behavior is shaped by a system that does not determine consequence. At this level, perception must shift again, from interaction to hierarchy. The system must identify which layer defines the field, not which system is loudest, but which system is final. Because dominance is not about influence over behavior, it is about control over outcome. A dominant system does not need to intervene constantly. It does not need to produce signals. It only needs to define limits. And within those limits, all other systems operate. This is why dominance often appears passive, because it does not react. It constrains. It shapes the environment in which reactions occur. At this level, understanding dominance changes strategy completely. The objective is no longer to align with every system. It is to identify the dominant one and align with that. Because alignment with a subordinate system creates friction, but alignment with a dominant system reduces it. Movement becomes efficient. Decisions become clearer. Outcomes become consistent. Not because conflict disappears, but because hierarchy is respected. This is the shift from reacting within systems to operating across them. Because once dominance is visible, behavior can be structured accordingly. Not based on preference, not based on visibility, but based on control. At this level, every action is evaluated differently, not by asking, what does this system want? But, which system will decide the outcome of this action? And once that is clear, conflict simplifies. Because even within competing logics, only one system defines the result. False alignment. Once dominance is understood, a critical mistake becomes visible. Alignment is not enough, because not all alignment produces results. At lower levels, alignment is treated as a universal solution. Identify the system, follow its rules, adapt behavior accordingly. This appears logical, and in isolated systems, it works. But within layered structures, alignment becomes conditional, because aligning with the wrong system produces failure, even when the alignment itself is correct. This is false alignment, a state where behavior perfectly matches a system's logic, but that system does not control the outcome. The result is confusion, because everything appears correct. The behavior is appropriate. The strategy is coherent, The feedback signals are positive, and yet the outcome does not follow. At this level, failure is not caused by error. It is caused by misplacement. The system has aligned, but with a subordinate structure. This creates a hidden inefficiency. Effort is applied, movement is generated, signals are reinforced, but none of it translates into control, because the dominant system remains unaffected. This is why false alignment is difficult to detect, because it does not feel wrong. It feels effective. It produces feedback. It creates the illusion of progress. But that progress is contained within a layer that does not define consequence. At this level, systems can reward behavior without allowing it to matter. They can amplify action without allowing it to influence outcome. This creates a loop, where behavior is continuously reinforced but never escalates. The system remains active but powerless. This is the trap, because the individual becomes more committed. They increase effort, refine strategy, deepen alignment, but all within the same layer, which means nothing changes. At this level, persistence becomes counterproductive, because it reinforces the wrong alignment. The more precise the behavior becomes, the more deeply it is locked into a system that cannot produce results. This is where most systems stall, not from lack of effort, but from misplaced alignment. They optimize within the wrong structure. At this level, correction requires detachment, not from behavior, but from feedback. Because feedback from subordinate systems is misleading. It confirms alignment, but not effectiveness. So the system must shift evaluation from, "Is this working within the system?" to, "Does this system actually determine outcome?" This changes everything, because it breaks the illusion of progress and forces reevaluation of structure. Which system is being aligned with? What level does it operate on? Does it define consequence or just behavior? Once this is clear, false alignment becomes visible. And once visible, it becomes avoidable. At this level, alignment must become selective. Not all systems deserve optimization. Not all feedback deserves response. Not all reinforcement indicates value. Only alignment with the dominant system produces outcome. Everything else produces motion. This is the distinction between activity and control. At this level, the system must be willing to disengage, to withdraw from structures that produce feedback but no consequence, to stop optimizing for systems that do not define the field. This creates a temporary instability because feedback disappears, reinforcement weakens, clarity drops. But this is necessary because it allows realignment with the system that actually matters. At this level, precision is not about doing more. It is about aligning correctly. Because once alignment matches dominance, results follow naturally. Not through force, but through structure. Structural leverage. Once false alignment is eliminated, a different question emerges. Not how to act, but where to act. Because action alone has no value, only placement does. At lower levels, leverage is misunderstood. It is associated with force, more effort, more output, more pressure applied to the system. This creates the belief that impact is proportional to intensity, that stronger action produces stronger results. But within layered systems, this assumption fails, because systems do not respond equally across all points. Some areas absorb action, others amplify it, and most of the field does nothing. This creates asymmetry, where identical effort produces completely different outcomes depending on where it is applied. At this level, leverage is not about doing more. It is about acting at the correct point within the structure. Because every system contains nodes, points where influence concentrates, not visible as objects, but identifiable through effect. A small change at these points propagates. It travels through pathways, reaches multiple layers, alters outcomes beyond its immediate location. These are leverage points, not powerful in isolation, but powerful in connection. At lower levels, these points are ignored because they do not appear significant. They do not generate strong signals. They do not attract attention. So action is directed elsewhere, toward visible areas, high activity zones, obvious pathways, immediate feedback loops. This creates effort without amplification. Because visible systems are often saturated, they distribute influence evenly, which means no single action produces meaningful change. At this level, the system must shift attention again, from activity to propagation. Not asking, where can I act, but where will this action travel? Because leverage is defined by movement, not local effect, but systemic reach. A leverage point is not where something changes. It is where change spreads. This requires mapping, understanding how systems connect, how pathways distribute influence, how feedback loops reinforce or dampen movement, where connections converge, where signals are redirected. At this level, leverage is structural. It is embedded in the architecture of the system, not in behavior, not in intensity, but in position. This is why small actions can produce large outcomes, not because they are strong, but because they are placed correctly. And why large actions often fail, because they are applied at points with no propagation. At this level, control becomes efficient, because it no longer depends on scale. It depends on placement. The system does not need to increase effort. It needs to identify the correct node. Once identified, action becomes minimal, but effective, because the system itself carries the change forward. This is the shift from force to leverage, where influence is not applied directly, but distributed through structure. At this level, timing also changes, because leverage points are not always active. Some nodes only amplify under certain conditions, when specific pathways are open, when feedback loops are aligned, when constraints are temporarily relaxed. This means leverage is dynamic, not fixed. A point that is effective at one moment may become neutral at another. So the system must track activation, not just location, but readiness. When is the system most responsive? When do pathways allow propagation? When does a small input produce maximum spread? This creates precision, because action is no longer constant. It is timed, placed, minimal, but decisive. At this level, behavior becomes strategic, not reactive, not continuous, but selective. Because once leverage is understood, most actions become unnecessary. The system stops engaging everywhere. It focuses on specific points and allows structure to do the rest. This reduces friction, because the system is no longer pushing against resistance. It is moving with architecture, using existing pathways, amplifying existing flows, redirecting existing signals, instead of forcing new ones. This is the difference between effort and influence. Effort acts locally, influence travels. At this level, leverage is the only form of action that matters, because it aligns with dominance. It operates within the system that defines outcome, and it uses the structure of that system to extend effect. This creates disproportion, where minimal input produces maximum result, not by chance, but by design. Threshold activation. Leverage alone is not enough, because not every correct action produces an immediate effect. At lower levels, this creates doubt. If the action is correct, why is nothing happening? Why does the system remain unchanged? Why does the structure resist movement, even when leverage is applied? This leads to a false conclusion, that the action was ineffective. So the system either increases intensity or abandons the approach. Both are errors, because within complex systems, change is not always continuous. It is threshold-based. At this level, systems do not respond linearly. They accumulate. Every input, every adjustment, every signal adds to a latent state, not visible, not measurable directly, but present. The system absorbs influence without expressing it. This creates a silent phase, where action produces no visible outcome, no feedback, no confirmation, no change in structure. But this is not inactivity. It is accumulation. The system is approaching a threshold, a point where accumulated inputs reach a level that forces transition. And when that threshold is crossed, change does not appear gradually. It appears suddenly. A shift, a reconfiguration, a new pattern of behavior that emerges without warning. At lower levels, this feels unpredictable, because the transition appears disconnected from the inputs. Nothing seemed to work until everything changed. But at this level, the process is precise. The system was responding the entire time, just not visibly. This is why most individuals misjudge timing. They expect continuous feedback. They expect linear progression. So when nothing appears to happen, they assume failure and stop, just before the threshold. This is where leverage is lost, because leverage requires persistence, but not in intensity, in placement. The same correct input, applied consistently at the correct node, accumulates, until the system can no longer remain stable. At that point, activation occurs. This is threshold activation, where the system shifts from one state to another, not gradually, but structurally. At this level, timing is misunderstood. It is not about acting at the right moment. It is about reaching the necessary condition. The moment is a consequence, not a choice. Once the threshold is reached, the system must change, because its current configuration is no longer sustainable. This creates inevitability, not prediction, but structural certainty. If inputs continue, the outcome is fixed. The only variable is when. At this level, control is not about forcing change. It is about understanding accumulation, knowing when to continue, knowing when to wait, and most importantly, knowing when not to interfere. Because interference can reset accumulation, disrupt alignment, break the progression toward threshold. This is why overreaction destroys leverage. Applying new strategies too early, changing direction before accumulation completes, seeking immediate feedback instead of structural shift. All of this delays activation. At this level, restraint becomes strategic, not passive, but controlled. The system maintains alignment, continues input at the correct node, and allows accumulation to build, without forcing visibility. Because visibility is not required, only condition. This is where patience becomes precise. Not waiting without action, but acting without expectation of immediate result. Because once the threshold is reached, change will not need to be forced. It will occur. At this level, systems do not resist forever. They resist until they cannot. And when that point is reached, transition is unavoidable. This creates clarity, because the system no longer depends on feedback. It depends on structure. Is the input correct? Is the placement correct? Is the accumulation progressing? If yes, then outcome is inevitable. Not immediately, but certainly. Perceived prediction versus structural reading. Once threshold activation is understood, a dangerous illusion begins to form. From the outside, it looks like prediction. Certain individuals appear to anticipate events before they occur. They move before shifts become visible. They position themselves before outcomes unfold. To an external observer, this creates a clear conclusion. They can see the future. But this is incorrect, because nothing is being predicted. At this level, what appears as foresight is simply structural reading. The system is not looking forward in time. It is reading conditions in the present, and those conditions already contain the outcome. At lower levels, events are perceived as isolated. A change happens, then another, then another. This creates a linear model, cause to effect, to next cause, to next effect. Within this model, the future appears uncertain, because each step seems independent. But at the level of systems, events are not isolated. They are connected through structure. Every outcome is the result of existing conditions interacting. Not random, not spontaneous, structured. At this level, once the configuration of a system reaches a certain state, its future behavior becomes constrained, not completely fixed, but heavily directed. Certain outcomes become more probable. Others become nearly impossible. This creates directional inevitability, not certainty in detail, but certainty in trajectory. And trajectory is what advanced perception reads, not the exact event, but the direction of movement. This is why operators appear predictive, because they act according to trajectory before it becomes visible as an event. They do not wait for confirmation. They read alignment. When multiple systems begin to align in a specific direction, the outcome is no longer open. It is forming. And once formation begins, timing becomes secondary. The structure will resolve. At this level, time is not the primary variable. Structure is. Events do not happen because time passes. They happen because conditions are met. Time only reveals what structure has already prepared. This changes everything, because it removes the illusion of randomness. What appears sudden was accumulating. What appears unexpected was forming. What appears unpredictable was simply not observed at the structural level. At this depth, prediction is unnecessary, because the system does not need to guess. It reads inevitability. Not absolute certainty, but constrained possibility, which is far more powerful. Because instead of asking, what will happen, the system asks, what can no longer be avoided? This is a completely different question, and it produces completely different behavior. At this level, action is not based on reaction. It is based on recognition. Recognition of structural pressure. Recognition of alignment. Recognition of threshold proximity. When these elements converge, movement becomes obvious. Not to everyone, but to the system that can read structure. This is why operators act early, not because they are faster, but because they are already positioned within the direction of movement. They do not chase outcomes. They move with them. This creates the illusion of anticipation, but in reality, it is synchronization, alignment with inevitability. At this level, error still exists, because structures are complex. Multiple systems interact. Trajectories can shift. But even this is not random. It is the result of new structural inputs, new alignments, new pressures, which means even change in direction can be read, if the system is sensitive enough. At this level, perception becomes continuous, not observing events, but monitoring structure, tracking how systems evolve, how alignment forms, how pressure accumulates, because within that process, the future is already taking shape, not as a fixed outcome, but as a narrowing field of possibilities. And once that field narrows enough, movement becomes inevitable. This is the difference between prediction and structural reading. Prediction tries to guess the future. Structural reading understands why the future cannot unfold differently. And once that is understood, timing becomes irrelevant, because the system is already moving. Pre-outcome positioning. Once structural reading is understood, action changes completely, because the objective is no longer to react to outcomes, but to be positioned before they emerge. At lower levels, positioning is reactive. An event becomes visible, then action follows. A shift occurs, Then adjustment begins. This creates delay, because action is always behind structure. By the time an outcome is visible, it has already been produced. At this level, reacting is inefficient, because the system is responding to something that is already resolved, not in appearance, but in structure. This is why reactive strategies consistently lose advantage. They operate in the visible layer, while outcomes are determined in the structural layer. At higher levels, positioning reverses this. The system does not wait for events. It aligns with trajectories. It identifies where the system is moving and enters that direction before manifestation. This is pre-outcome positioning, not based on prediction, but on inevitability. At this level, the system does not ask, "What is happening?" It asks, "What is forming?" Because formation precedes appearance. And once formation is clear, appearance is only a matter of time. This creates a different relationship with action. Instead of responding to change, the system participates in it early. It places itself within the pathway of emerging outcomes, not forcing movement, but aligning with it. This reduces resistance, because the system is not pushing against structure, it is moving with it. At this level, timing is no longer reactive. It becomes anticipatory, not in the sense of guessing, but in recognizing readiness. When conditions are sufficiently aligned, positioning occurs. Not too early, where alignment is incomplete. Not too late, where outcomes are already visible. But within the formation phase, where structure is stable enough to read, but not yet visible enough for others to act. This creates advantage, because action occurs within low competition space, before visibility increases, before systems begin reacting, before constraints tighten. At this level, positioning is not about speed, it is about entry point, where within the structure action is placed. Because entering too early creates exposure. Entering too late creates limitation. Only entering within the correct window creates leverage. This window is not defined by time, but by structure. When alignment reaches a certain level, but before threshold activation completes, that is the point. At this level, positioning also requires restraint, because not every trajectory should be followed. Not every alignment leads to a favorable outcome. The system must evaluate which direction leads to control, which leads to constraint, which expands influence, which compresses it. Because positioning within the wrong trajectory amplifies the wrong outcome. And at higher levels, amplification happens quickly. This is why precision matters. The system does not chase every movement. It selects, based on structure, not on visibility, not on noise, but on underlying configuration. At this level, positioning also becomes less visible, because effective placement does not require signal. It does not need to be seen. It does not need to be recognized. It only needs to be correct. This creates asymmetry, where action is minimal, but outcome is significant. Because once positioned correctly, the system no longer needs to act continuously. The structure carries the result forward. This is where most misinterpretation occurs. Observers see the outcome, but not the positioning. They see the result, but not the timing. They assume action occurred at the moment of visibility. But in reality, the decisive action happened earlier, within the formation phase, invisible. At this level, control is silent, because it operates before confirmation, before validation, before recognition. This is uncomfortable at lower levels, because it requires acting without feedback, without immediate result, without visible confirmation. But at this level, feedback is not required, because structure is. If alignment is clear, action is justified. If trajectory is stable, positioning is correct. Outcome will follow, not instantly, but inevitably. This is the shift. From reacting to outcomes, to entering them before they exist. Non-reactive control. Once pre-outcome positioning is established, a final misconception remains. Control is not reaction. At lower levels, control is defined by response. Something happens, and the system reacts. An input appears, and the system adjusts. A disruption occurs, and the system intervenes. This creates the illusion of control, because action is visible, because response is immediate, because the system appears engaged. But this is not control. It is adaptation. And adaptation is always secondary. At this level, reaction follows structure. It does not define it. The system is responding to conditions that already exist, not shaping the conditions themselves. This is why reactive systems remain limited. They operate within constraints instead of defining them. They adjust to movement instead of determining direction. They follow outcomes instead of structuring them. At higher levels, control operates differently. It is not expressed through response. It is expressed through stability. The system does not react to every signal. It does not respond to every fluctuation. It does not engage with every disturbance, because most signals are noise, and reacting to noise introduces instability. At this level, control is selective, not in action, but in attention. The system filters. It distinguishes between signal and noise, structure and variation, change and fluctuation. Only structural shifts require response. Everything else is ignored. This creates stillness, not inactivity, but controlled non-engagement. The system remains stable, even when movement occurs around it, because it is not influenced by surface-level changes. It is anchored in structure. At this level, control becomes silent, because it is no longer visible through action. It is visible through consistency. The system maintains direction without constant correction. It preserves alignment without continuous adjustment. It allows fluctuations without being affected by them. This creates resilience, because the system is not reactive. It is stable under variation. At this level, control also becomes indirect. The system does not intervene directly in every outcome. It shapes the conditions under which outcomes emerge. This is a different form of influence. Instead of reacting to events, it structures the environment, defines the boundaries, controls the pathways, regulates the flow, so that outcomes naturally follow, without intervention. This reduces effort, because the system is no longer managing individual events. It is managing structure, and structure determines behavior at scale. At this level, reaction becomes inefficient, because reacting to every change disperses control. It spreads attention across multiple points, weakens focus, introduces inconsistency. Non-reactive systems avoid this. They concentrate influence, maintain coherence, and act only when structure requires adjustment. This creates precision, because action is no longer frequent. It is necessary. At this level, non-reaction is not passivity. It is control over engagement. The system chooses when to act and when not to. And this choice is based on structure, not emotion, not urgency, not visibility. Because urgency often comes from noise, and visibility often masks irrelevance. Only structural shifts matter. At this level, control also becomes less observable, because there are fewer visible actions, fewer reactions, fewer interventions. From the outside, the system appears inactive, but internally, it is stable, aligned, and positioned. This creates asymmetry, where other systems react constantly while one remains still. And over time, this difference compounds. Reactive systems lose coherence. They adjust too often, change direction too frequently, dilute their structure. Non-reactive systems maintain it. They preserve direction, sustain alignment, and accumulate stability. This is where dominance begins to form, not through force, not through frequency, but through consistency. At this level, control is not about doing more. It is about doing less, but correctly. Ignoring what does not matter, engaging only with what defines structure, and allowing the system to operate within those conditions. This is non-reactive control, not absence of action, but absence of unnecessary action. And within complex systems, that is the highest form of precision. System dominance. Once non-reactive control is established, the structure resolves, not gradually, but decisively. Because at this level, systems do not remain in conflict indefinitely. They converge toward dominance. At lower levels, dominance is misunderstood. It is associated with force, control through pressure, influence through visibility, power through direct action. But within layered systems, dominance does not emerge this way. It is not imposed. It is stabilized. A dominant system is not the one that acts the most. It is the one that defines the field, the one that determines what is possible, what is limited, what is amplified, what is suppressed, without constant intervention. At this level, dominance is structural, not behavioral, because behavior operates within boundaries, and boundaries are set by structure. Once a system defines those boundaries, everything else adjusts, not by choice, but by necessity. Other systems do not disappear. They continue to operate. They produce signals. They generate movement. They create variation. But all within constraints defined by the dominant system. This is why dominance often appears invisible, because it does not need to assert itself. It is already embedded. At this level, conflict does not end because systems agree. It ends because one system defines resolution. Other systems no longer determine outcome. They operate within limits. This creates coherence, where previously there was tension, where multiple logics competed. One becomes primary, not eliminating others, but organizing them. At this level, dominance produces simplicity, not by reducing complexity, but by structuring it. The system does not remove layers, it aligns them. All pathways begin to move in a consistent direction. Feedback loops reinforce the same outcomes. Constraints support rather than oppose. This creates flow, not absence of resistance, but absence of contradiction. Movement becomes efficient, because the system is no longer divided. It operates as a unified structure. At this level, dominance also stabilizes time, because once a system defines the field, variability decreases. Outcomes become more consistent, not identical, but predictable within a range, because structure limits deviation. This is where control reaches its highest form, not controlling individual events, but controlling the range of possible outcomes. The system does not dictate exact results. It defines what results are possible, and everything outside that range does not occur. At this level, power becomes quiet, because it is no longer expressed through action. It is expressed through limitation, through constraint, through invisible boundaries that shape behavior without being seen. This creates asymmetry, where one system determines the field and others operate within it, even if they appear active, even if they generate movement, even if they seem influential. Their influence is contained. At this level, dominance is not challenged easily, because it is not located in a single point. It is distributed, embedded across structure, reinforced through pathways, maintained through feedback loops. To disrupt it requires structural change, not behavioral opposition. And structural change is rare, because dominant systems stabilize themselves. They adapt when necessary, absorb pressure, reconfigure without losing control. This is why dominance persists, not through rigidity, but through adaptability within structure. At this level, the system reaches clarity. It no longer reacts unnecessarily. It no longer aligns incorrectly. It no longer acts without leverage. Every action is placed. Every movement is aligned. Every outcome is contained within defined boundaries. This is system dominance, not as an event, but as a state. And once reached, it becomes the reference point. Other systems adjust to it, not because they choose to, but because they must. At this level, the system is no longer navigating structure. It is defining it. Most systems remain trapped in reaction. Some learn to navigate structure, but the rarest systems do not follow. They define. Chapter 2 begins where dominance is no longer understood, but engineered.